This is a graphic representation of a possible war scenario. Just over 30 nautical miles separate friendly from hostile territory. Our objective is to transport the men and equipment required to conquer the enemy headquarters, situated about 12 miles inland, in a place surrounded by 3,000-foot hills. The enemy is defended by numerous anti-aircraft artillery positions around the HQ, situated at a short distance from civilian dwellings. Our fleet is 15 nautical miles off the enemy coast, and a heavy artillery battery is stationed on the other side of the channel, 55 miles from the enemy positions. A pair of unmanned aerial vehicles will follow the action to allow initial discovery and target designation, and after the action, the kill assessment. While helicopters take off from the ships, the PZH-2000 battery is ready to fire. 155mm Vulcano projectiles are programmed for navigation and for the terminal phase of guidance. Firing is the first of 3 stages that allows the projectiles to reach the target. The projectile loses its sabot and, as it follows the ballistic trajectory, it starts initializing the GPS receiver and IMU equipment on board. A few moments after passing the apogee, during the second or intermediate stage, thanks to the movement of its canard fins, the projectile will gradually begin to control the angle of descent, the pull-up maneuver. The pull-up maneuver allows the projectile to glide in a straight line for a few hundredths of a second, that ideally guides it onto the target, about 6,000 feet. This constant angle descent, using mainly satellite guidance, is also used to refine the inertia measurements of the IMU and the estimate of the angles of flight. During the terminal guidance stage, as it approaches the target, the projectile performs a pull-down maneuver to optimize terminal efficiency against the designated target and to minimize the effect of any countermeasures. This is because when the projectile is close to the target, it can no longer receive GPS data due to jamming. Should this occur, the projectile will continue its course towards the target using inertial navigation only. Since the angle of descent can be controlled during the intermediate stage of flight, projectiles fired in succession can reach the target simultaneously, thereby maximizing the effect of surprise, which is called the MRSI technique. All targets are hit simultaneously and cause no collateral damage. The enemy leaps into action. 3 tanks emerge from a tunnel concealed in the mountainside and make for HQ. The UAVs witness the maneuver and communicate the tanks' current positions to the ships. On board, the 127-54LW enters the firing sequence. It shoots a rapid burst of 5 127mm Vulcano rounds equipped with a semi-active laser receiver that enhances accuracy and hence terminal efficiency both against stationary and moving targets, or in engaging moving targets. In this case, during the terminal phase, the projectile will be guided towards the source of the laser ray reflected by the target. This requires the aid of a support for targeting, in our case, the UAVs. The projectiles have been fired with different flight profiles. They reach the target at different times and from different directions. This enables the UAVs to retarget other engageable objectives, but it could also be useful to conceal the position of a naval unit or to avoid natural or artificial obstacles. Our operation can now proceed, and the helicopters may land safely. The satellite indicates a naval unit making for our fleet. The onboard radar shows that the range is 13 nautical miles. The 127-54LW gun is loaded with Vulcano ammunition, equipped with an infrared sensor that activates in the terminal flight phase. and is designed and optimized for use against surface targets. During the initial and cruising stages, the projectile follows a ballistic trajectory. At a range of about 4 miles, the infrared sensor begins to seek out the hottest point of the target and guides the projectile towards it. Once it has been fired, the ammunition requires no support, either from the shipboard system or from elsewhere. An infrared sensor used for terminal guidance performs very well against small moving targets situated well beyond the range of conventional ammunition. The Vulcano crosses new frontiers in technology.